Welcome to video number 2 for A Helping Hand. In this video, we'll be discussing clues 2 through 9 and how you might be able to guide your students to discovery. Okay, so let's talk about clue number 2. Clue number 2 is similar to clue number 1 in setup and guidance, in that you'll be handing them these clues and you'll be telling them that, oh, and as you walk around in this new town, you hear someone trade 2 jackets for 3 first aid kits. And you'll ask them to then decide which of these are more expensive. This one is perhaps a little bit better for representation pictorially in terms of quantity, since there are only 2 jackets traded for 3 first aid kits. Okay, so let's see. We know from the trade that 2 jackets must be equal in value to 3 first aid kits. Algebraically, you can see that this means that 3 halves, or that a jacket is worth 3 halves of a first aid kit. You can use this to then determine which are more expensive, 5 jackets or 8 first aid kits, because now we have each of these expressions in terms of either jackets or first aid kits, depending on how you choose to write your ratios, or maybe whatever your students discover first. I'm going to go with a jacket is equal to 3 halves the price of a first aid kit. So we have 5 times jackets. We use a substitution from the equation above to write 5 times 3 halves f. So now we have 15 halves, and the reason I'm emphasizing halves is because you can perhaps relate fractions to just numbers of things, like numbers of socks, by saying it's 15 halves instead of like 15 divided by 2 or 15 over 2 or anything else. This might be helpful in them reasoning through this problem. Okay, so now we have 5 jackets in terms of 8 kits. 15 halves is equal to, 15 halves times the first aid kit is equal to 1 half plus 14 halves. So you can see, like, it's easy to think about 15 of something rather than 15 or 15 halves, or like 15 divided by 2, 7.5, whatever that is. Oh, speaking of which, we can determine, or we can compare 5 jackets to 8 first aid kits using this equation here. So 14 divided by 2 is 7. So this is 7 plus 1 half first aid kits, which we can see is less than 8 first aid kits. This means that 5 jackets are, more expensive. 8 first aid kits are more expensive than 5 jackets. There are a number of ways that you can guide your students through this activity with pictures. In particular, your students might find it easier to think of blocks. So for example, the original trade says that you have that 2 times the price of the jackets, or 2 blocks times the price of the jackets, is equal to 3 times the price of the first aid kit. And so we could rewrite the purely numerical values that we wrote earlier in terms of these pictures. We can talk about like 3 being divided into 2 things, like so, depending on your students' grasp on mathematics. This can be kind of difficult for students, so you might want to use the word like, say, like, suppose, or say like, gosh, use things like saying like 3/2 of F is equal to a jacket. And that's like 3 of something is equal to something else. Is a little bit easier for them to handle because now they're only dealing with numerators, the denominator is just a unit that you're using. Okay, so 5 jackets can be rewritten or drawn as 5 times this picture here. And that's the 3 blocks on top over the 2 blocks underneath times F. So this is 5 times 3/2 F. Might be a way that you would verbalize this in words. And then we can talk about 5 times 3 of something is 15 of that something. So this is equal to, and you might want to draw out all the blocks. I don't, I did it earlier when I was writing the script, and I think you get the idea. And so this might be a way to pictorially represent these quantities in terms of blocks with your students. And it might make the mathematical reasoning a little bit easier because now instead of thinking about fractions, they're thinking about halves of something, which is kind of like a unit now in some sense. Okay, so I think that's it for clue number 2. Whoops. Let's talk about clue number 3 and get some room here. Okay, in this clue, your students are given a lot of information, and it might be helpful to tell them, okay, so we got to keep track of all this information. Remember the activity where we were trying to determine the efficacy or how effective these drugs were that were treating this brain disorder? Yeah, we use tables to do that. Let's try and use tables to organize this information and see if we can't make sense of it. So something you might want to do is say, okay, well, let's look at each of these conversations that we overhear while we're walking around town and write down the information and see if we can't notice anything. So a good way to do that, and you could explain to your students that you maybe want to make 2 columns, one with radios, how many radios were transferred for how, or how many radios were traded for how many flashlights. It is flashlights, right? Yeah. So you can look at these conversations and you'll see that you get 3 radios traded, 5 radios traded, 15 radios traded, 5, 30. I wrote this down in advance and that's why I'm looking at my notes. 19 and 9. So 3 radios were traded for 7 flashlights. 5 radios were traded for 13 flashlights. 15 radios were traded for 38 flashlights. 5 radios were traded for 12 flashlights at a different time or by a different pair of traders. And 30 flashlights were traded for 30 radios were traded for 99 flashlights. And 19 radios were traded for 48 flashlights, and 9 radios were traded for 23 flashlights. Here's a table that perhaps you could expect your students to write down, given this information and a little bit of guidance. Something that would be really important to point out to your students, especially with regard to this question, is this information more or less consistent? It's inconsistent. I don't know about more or less, but it's inconsistent because, look, 5 radios were traded for 2 different numbers of flashlights in this case. So clearly we can say that this information is inconsistent or less consistent perhaps. I don't know what it means by being too variable. Don't know how I would explain that. But let's look at some other observations we might be able to make from this data. For example, the first trade implies that if we have 3 radios is equal 7 flashlights, this means that radio price is equal to 7/3 the price of a flashlight. But 7/3 is kind of a hard thing to think about. What might be easier is writing this as a sum of 2 simpler fractions that are easier to understand and compare to other simple fractions. I don't know if that's the right word, but I'm using it. So R is equal to, in this first case, 7/3 is really just 1/3 plus 6/3 times the price of a flashlight, which you may recognize as 1/3 plus 2 times the price of a flashlight, or 2.3-ish times the price of a flashlight. So you can see here that a radio should be more expensive than a flashlight based on these exchange rates. You can do this same analysis with other entries. For example, here we see that we have a radio is worth 99/30ths of a flashlight. Or simplifying, you can talk to your students about like, well, okay, I see a factor of 3 in 30. 30 is 3 times 10. And I see a factor of 3 in 99 because 3 times 33 is equal to 99. So we can simplify this fraction to be 33/10 of the price of a flashlight. Again, it's easier to see this in terms of a simpler fraction. So 33 is really 3 plus 30. You can write this as 3/10 plus 30/10, where in the right-hand summand, I know, I'm a poet and I didn't even know it, there is a common factor of 10 because 10 times 3 is 30, and we can divide that out to find that we have 3 plus 3/10 of the price of a flashlight is equal to the price of a radio. In particular, you might be able to say something like, if your junior and high students are comfortable with going from fractions to decimals, this is 3.3 times the price of a flashlight. And so we can see here that the ratio between the prices of flashlights and radios varies. So perhaps that's what we mean by 2 variable, is that the price varies. And the calculations above here are how we know that to be true. You can also use things like bar models to talk about this and other pictorial representations, but for the rest of the clues, I'm going to focus more on getting you to understand the mathematics in more of like an algebraic sense, so that then you can spend time with your students on a case-by-case basis to determine how best to represent this information pictorially or through manipulatives or whatever other tools you may have at your disposal. So let's move on to clue number 4. The price of a meal is 1.5 times the price of a flashlight. Okay, here it might be useful to compute the ratio like so. So we have 2 times the price of a meal is equal to, so 1.5 is really 3 halves, if memory serves, because 3 halves is equal to 1/2 plus 2/2, which is 1/2 plus 1, which is 1.5. It might be helpful for your students to break things up like that and explain it piece by piece, so that If you have students that seem to be a little lost, then this might be helpful for them. Okay, so we have 2 meals is equal to 3 halves the price of a flashlight. This means that the price of a meal is really equal to 3/4 the price of a flashlight. Now, we're asked to decide which is more expensive, 49 meals and 42 flashlights, or 52 meals and 41 flashlights. Once you work with your students to get them to realize this ratio or the other way around, then you can substitute into these 2 expressions to get that to eliminate the other variable to determine which is more expensive. So we have 49 meals plus 42 flashlights. Well, we want to figure out this price in terms of price of flashlights or price of meals. Let's go with price of flashlights. Whoops, decided I wanted L for flashlights. That was a terrible choice on my part. So we have 49 times 3/4 L plus 42 L. So what you might want to do is multiply 42 by 4 and write it as 42 times 4 over 4. So you have a common denominator, and the addition is going to be easier for your students so that they can simplify and come up with a value for the right-hand side here. So let's see, we have 147, because that's 3 times 49 quarters, or fourths, or however you want to say that, plus 168 quarters, because 4 times 42 is 168, I think. I don't know. I didn't check that. You'll want to check that. Gosh, adding 147 of something plus 168 of something is difficult. Adding 100 to 100 is easy, though. So let's add this by hundreds place, tens place, and ones place to make this simpler for your elementary school students or junior high students. We have 100 plus 100 is 200, plus 60 plus 40 is 100, plus 7 plus 8 is 15 quarters L. So this is 300 plus 15 is 315 quarters L. Now what you want to do is perhaps use the same substitution to eliminate one of the variables in the second expression to determine what the price is in terms of flashlights. So here I'm going to, maybe I shouldn't. No, I won't skip steps. So we'll have 52 meals plus 41 flashlights is equal to 52 times 3/4 L. Oh, and this is really handy because 52 is divisible by 4. If you don't believe me, 50 divided by 2 is 25. So 52 divided by 2 is 26. 26 is an even number. It's 2 times 13. So this will be really convenient. And you can talk about maybe like 52 is 4 times 13 or something like that for your students to maybe see this insight and add these numbers. So we have 41L here, which is equal to 13 times 3 is 39L plus 41L, and 30 plus 40, again, let's do tens addition and then ones addition. 40 plus 30 is 70, plus 1 plus 9 is 10, so that's 80L. I think I might have messed this one up. 80L. Let's see, 70, yeah, I guess that's right. For 52, 13 times 3, 39, yeah. Okay, 80L, but we want to compare this to 315 quarters L, the first expression. So we need to write this as something over 4. In order to do that, you will multiply by 1 in the special form of 4 over 4. So this is equal to 4 over 4 times 80L. So 4 times 8 is 32, times 10 is 320 quarters L. And we can see that 320 quarters is more than 315 quarters, which means that the second expression is a larger value, or it's more expensive to buy 52 meals and 41 flashlights than it is to buy 49 meals and 42 flashlights. If my arithmetic is correct, you'll want to check that. And yeah, we'll move on to the next one. So for clue number 5, $2 worth of a meal is equal to $18 worth of water tank. So this means roughly that $1 worth of meal is worth $9 of water tank. So K meals, and K is going to be the number of meals, costs the same as K over 9 water tanks. So if we have one meal, this is equal to 1/9 of a water tank. And let's go back with my abbreviation here. So the price of one meal is 1/9 the price of a water tank. So let's say we want to know how much it costs for 9 meals. Then we know that it's 9 over 9 tanks, which is 1 tank. Okay, so what about 18 meals? Well, this is equal to 18 over 9 tanks, which is simply 2 tanks. And I'm choosing my numbers wisely here because I don't know how to do arithmetic, and so I'm choosing the easiest thing I can think of. We have 27 meals is equal to 27 over 9 tanks, which is 3 water tanks. So you can get 27 meals for 3 water tanks, or it costs, or so 27 meals cost the same as 3 water tanks. This gives us a direct comparison between the prices of each, and we know that the relationship in groupie, or the ratio in groupies will be the same, since there's going to be some constant, hopefully, trade value between the two currencies. Okay. And then you'll want to maybe treat the secondary questions like a proposal and stuff at the bottom as like a side mission, an extra bonus mission where you help people out in the town that you're visiting to try and determine how to do things fairly. Okay, but let's move on to clue number 6 as this video is getting long. The clue starts to give students an idea of the exchange rate between groupies and dollars, and also starts to give a price of an item. In particular, it gives you the price of a jacket and a water tank. Once you figure out the ratio between these two prices, you can then use that information to get the price in groupies of a jacket or a water tank, and then use that in conjunction with other information, which we'll talk about it in the third video. Okay, so enough of me rambling. We can see from the pie chart that a tank costs 3 times as much as a jacket. So 3 jackets cost the same as 1 water tank. In particular, we can use this to say a number of things. Let's see, and how do I know it's 3 times, or 3 jackets cost the same as a water tank? Well, for percentages, you'll want the total percentage to add up to 100% or close to it, like 99%. If there are fractions with repeated decimal expressions or irrational numbers, then you want to say like you want to round up to like larger numbers here. So we can see that 3 times 25% is equal to 75%. And so that's where this relationship comes from. Okay, so we want to draw a pie chart that'll give us the price of 2 tanks versus 12 jackets. So first, let's think about the math algebraically, and then we'll discuss the pie chart representation. So we have 2 tanks, and from the relation above, we know that 2 tanks is equal to 2 times 3 jackets, or 6 jackets. So 2 tanks is equal to 6 jackets. This could also be written as, yes, this will probably be helpful. This can be written as 1/2 12 jackets, because we are interested in the price of 2 tanks to 12 jackets. We have 6 jackets. How do we get 12 jackets? Well, 1/2 of 12 is 6, so we can write this. And so now we have that the price of 2 tanks is equal to 1/2 the price of 12 jackets. So we are going to want 2 numbers that add to 100 and whose ratio satisfies this equality here. So I recommend that you check this out, but try 33 times 2. This is 66. So we have 1/2 of 66 is equal to 33. And 33 plus 66 is equal to 99. This is the case where you have repeated fractions, and you'll want to use something close to 100 for your total percentage to get like a visual intuition for how you should divide up the pie chart. Okay, so we have a circle here, if I can draw one, using the help of my software here. We have that. 2/3. It's good when drawing these to start at the top and move to the center or somewhere close to the center, as you might be a better drawer than me. So 1/3 of the way around is about here. So I'm going to draw another line. Oh no, Microsoft, you failed me. Let's get rid of that and draw another line here. Why? Okay, I'm done with trying to do that. There we go, close enough. So this is about 2/3. So this is the price for 2 tanks versus 12 jackets. And I invite you to play with that in order to verify that or perhaps correct it. Okay, so let's talk about clue number 7. Here we have the pictorial representation of 5 first aid kits is equal to 3 radios. So we have a ratio of 3/5 the price of a radio is equal to the price of a first aid kit. So we're asked to decide which is more expensive, a radio or a first aid kit. Since 3/5 is less than 1, because it's less than 5/5, this means that the price of a radio is less than the price of a first aid kit. Or I'm sorry, the other way around. So the price of a radio is sorry, hold on, I lost my place in my notes. So radios are more expensive than first aid kits. So radios are more expensive, yes. Than first aid kits. Why is that true? Because the price of a first aid kit is a fraction less than 1 of the price of a radio. So first aid kits are less expensive than radios, and so we can say that radios are more expensive. And you can use the pictorial representations of these objects. You can write an algebraic expression if your students are comfortable with that. These ratios, or maybe talking about the fraction of the price of a radio is equal to the price of a first aid kit, meaning that it's less than the price of the radio. Okay, I'm getting lost here. Let's go on to clue number 8. From the graph, we see that for $10 spent on a radio, we get $3 worth of a meal, worth of the price of a meal. By looking at the vertical axis value and drawing, so if we look at, oh boy, I should have made this larger, but let's see. If we look at the price 1 and then go to the right here until we hit the line, then we come down to 3 here. Sorry if it's hard to see. We get this idea that there's like this ratio. Maybe you can use something like if your students got to linear equations for the brain disorder activity, you could start talking about rise over run of this graph. And so you can see that the price of a meal is equal to rise, which is 1, over run, which is 3, and you can help your students compute this if you like, times the price of a radio. So we can see that the meal is only 1/3 the price of the radio, whatever the price of the meal is. And this seems to be constant, so that's interesting. Yeah. Oh, I'm sorry. Let's see, what do I want to say? Something might be helpful is here at 3, we can go to the right. And then we hit the line at 10. So we have the following relation that might also be helpful. So we have 3 meal, 3m is equal to 10r. Or I'm sorry, I wanted it the other way around. So we have 3r is equal to 10m from that graph, which means that the price of a radio is 10/3 the price of a meal. And you can see this as rise over run, where you take the reciprocal of the graph that I was talking about earlier. Yeah, okay. So we have this. This means that we have m is equal to 3/10 r. So in similar reasoning to clue number 7, we can say that the price of a meal is less than the price of the radios, because the price of a meal is 3/10 the price of a radio. And again, slope, rise over run discussions might be helpful in discovering this. And if you choose a value, vertical value of 3, the horizontal value of 10, it's easy to draw this on the graph with your students, and maybe they can see this as well. Okay, so the price of a radio is price of radio R is equal to 10/3 the price of a meal. So we can see that a radio is more expensive as in the previous discussion. Okay, and so here in this picture, you want to guide your students into maybe figuring out, well, if you have 3 meals over here and 1 radio, then how many of each do you need over here in order for this thing to be equal? Yeah, okay, moving on to the final clue, clue number 9. This one, I think I am going to explain purely algebraically, and I'll leave up to your creativity to maybe guide your students through this. So if D is a number of dollars and G is the number of goopies, then we have from the picture $100 plus 6 times 500 is 3,000 goopies is equal to a total of $220. Subtracting $100 from both sides, we have 3,000 goopies is equal to $120. Okay, I am seeing factors of 3 on both sides. So we have 1,000 goopies is equal to $40. Oh, I'm seeing factors of 4 on both sides. 500, 250. So we have 250 goopies is equal to $10. And oh, look, we see factors of 10 on both sides. We have 25 goopies is equal to $1. So every dollar is worth 25 goopies. What an interesting name. So which is more valuable? $1 or 1 goopie? $1 is more valuable since it's worth 25 goopies. Okay, that has been a crash course in clues 1 through 9. I hope you've understood the problems and you've maybe thought about a way in which you can guide your students into this understanding. And I will see you in the next video. Until then, what was I saying? Arrivederci? Arrivederci.